All right, so we're going to go over questions 7 through 12 on graphing radical functions or square root functions. So when you're graphing a function, you want to be able to identify the critical point, right? So we are looking for A, H, and K. A is our stretch, compress, reflection. H is our shift left and right. K is our shift out. The critical point will always be H comma K. All right, so we'll always have the H comma K. In this case, for number 7, that's 0, 0. So our critical point is 0, 0. All right, so we have two options. We can make a table of values. Okay, and when we make a table of values, we want to choose x's that will make a perfect square. All right, so that way we don't have it. So this one's pretty easy. All right, and so because it's just x, so just the perfect squares. So 0, 1, 4, 9. Okay, we'll plug those in. Okay, and then we can get our answers, right? Square root of 0 is 0. 0 times 1/2 is 0. Right? 0 times square root of 1 is 1. 1 times 1/2 is 1/2. Square root of 4 is 2. 2 times 1/2 is 1. Square root of 9 is 3. 3 times 1/2 is 3/2. Okay, so we can just plug it in and get our answer. All right, and then so we plot those points: 1, 1/2, 4, 1, 9, 1.5. So just a little off the graph there, but we're fine. So our graph will look like this. Okay, and so I want you to notice, right, what are the x's growing by, right? 1, 3, 5. That is always the case for x's. So if it's not just a perfect square in there, so wherever you start the critical point, then you just add 1 for the x, and you add 3 for the x, and you add 5, and so on. The y's will always grow by a, right, or decrease by a. Like in number 8, they're going to go down by 4/5. Okay, so but here it's up by 1/2. So 0, 1/2, 1, 1.5. All right, so you can actually graph without a table of values, okay, just by following that up a over 1, up a over 3, up a over 5 pattern, right? And then we need to do our domain and range. So we'll just use interval notation for the domain. Okay, so it starts at 0 and goes to infinity. So 0 to infinity, right? Or all positive real numbers, including 0. So all real numbers greater than or equal to 0. Okay, my range is going to be the exact same thing here, right? The smallest y value is 0 and it goes up forever. So my range will be the same. All real numbers greater than or equal to 0. All right. Okay, number 8. Okay, so same situation here. There's no h and k, so my critical point is 0, 0. Okay, this time, all right, it's the a is negative 4/5. So that's almost what's 0.8, right? So you're down 0.8 over 1, down 0.8 over 3, down 0.8 over 5. So it's going to get you a little bit off the graph there. And so my graph is going to look like this. We'll just check our table of values and make sure we're good. Again, you start your table of values at the critical point. So in this case, 0, 0, HK. All right. Add 1, add 3, add 5. That's how you get your x's. If you plug in 1, square root of 1 is 1, so you get negative 4/5 or 0.8. Plug in 4, square root of 4 is 2, so now you get negative 8/5. Or if you like decimals, negative 1.6. Plug in 9, square root of 9 is 3, so now you get negative 12/5. If you like decimals, that's negative 2.4. All right, and there's your graph. So here my domain is going to be the same as the previous one. The smallest one, 0, and goes to the right forever. So 0 to infinity. All real numbers greater than or equal to 0. But my range, okay, is now going down. So 0 is the highest point. So it's going to start at negative infinity and go to 0. So you'd say all real numbers less than or equal to 0. All right, jumping down to number 9 now. Okay, rad x plus 3. So this 3 is outside the radical, so it's a k. So my critical point is going to be 0, 3. That's where I'm going to start at. All right, using the pattern, a is 1, so up 1 over 1. Up 1 over 3. Up 1 over 5. And so there's my graph. All right, table of values. Again, technically, if I already have the graph made, I don't need the table of values. But we want to practice, so we should probably do the table of values first. Okay, so kind of just mixing it up so you see it. Okay, so you start at 0, 3. Remember, add 1, add 3, add 5. That's how you get your x's. You plug those in. Okay, so square root 1 is 1. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. So that's going to go up 1, which again is your a. All right, domain is the same as before. Starts at 0, goes to infinity. So all real numbers greater than or equal to 0. And then my range here, what's my smallest y value is 3. So my range is going to be all real numbers greater than or equal to 3. So bracket 3 to infinity. All right, so 10, now I've got square root of x plus 5 plus 1. So now my h is negative 5. Okay, so it's negative 5, and my k is 1, so my critical point, negative 5, 1. So that's where I'm going to start at. So if we do the table of values first, that's what I'm going to put in there first, is my critical point. All right, and then I add 1, so that's negative 4. I add 3, that's negative 1. Right, add 5, that's 4. That's it. What that's going to do is going to make everything inside the radical a perfect square, right? So if I do negative 4 plus 5, that's 1. Square root of 1 is 1. 1 plus 1 is 2. Again, since a is 1, these should all go up. This should be 3. This should be 4. But let's just double check, plug in 4. 4 plus 5 is 9. Square root of 9 is 3. 3 plus 1 is 4. All right, so we can plot these points. Negative 4, 2. Negative 1, 3. 4, 4. And we have our graph. Okay, domain, okay, smallest x value is now negative 5. So my domain is all real numbers greater than or equal to negative 5. So negative 5 to infinity. And my range, my smallest range is my 1, my k. So now it's from 1 to infinity, all real numbers greater than or equal to 1. We have our range. All right, last two. Okay, so now again, there's no h here. That 2 is on the outside, so that's k. So my critical point is 0, 2. All right, my a is 1, so up 1 over 1. Up 1 over 3. Up 1 over 5. So not much different, right, than that one. It's one spot lower. Same exact graph, one spot lower. Oops. Okay, so my domain is everything greater than 0, greater than or equal to 0. My range is everything greater than or equal to 2. All right, table of values real fast. Again, you're going to get 0, 2. All right, 1, 4, 9, and then these just go up by 1. 3, 4, 5. All right, now 12, I have an a here that's negative 2. All right, so now instead of just going up by 1 over there, now it's going to be going down by 2. So down by 2 over 1, down by 2 over 3, down by 2 over 5. All right, so again, my critical point here, h is 0. Okay, k is 3, so my critical point is 0, 3. All right, that's going to be my first point of my table of values. Okay, so again, it's 1, 4, 9. Okay, and so now this is going to go down by 2. So 1, negative 1, negative 3. And let's just double check. If I plug in 9, right, square root of 9 is 3. 3 times negative 2 is negative 6. Negative 6 plus 3 is negative 3. All right, so that pattern is true. All right, always true. Okay, so 1, 1, 4, -1, and 9, -3. Or sorry, yeah, -3. Is that it right there? Okay. All right, so my domain is all real numbers greater than or equal to 0, 0 to infinity, and my range is all real numbers less than or equal to 3, so from -infinity to 3. All right, and there you go. That's how you are going to do 7 through 12.